Good morning to everybody. Last database object in every database, that is index, that is administrator creating only. What is the purpose of index database object? Means indexed columns we are using in a where clause or order by clause, then very fastly retrieve the data compared to normal queries only. How means, why means, I will tell you. But how many ways they are creating indexes? That is two ways. One is automatically, another one is manually. Automatically means whenever we are creating a primary key or unique constraint in any database, then automatically database servers creates a what B-tree indexes on those columns. What is B-tree index? Today we are learning. Again, manually also we are creating administrator creating index, that is create index name on table name, column name. Up to this one we are discussing a what a previous class. First step is now here. Why indexed columns only, indexes only improve the performance, very fastly retrieve the data means reason is there. That searching mechanism is totally different. What is that one means I will tell you, but before that one, this theory write it. Next para. Generally indexes are used to improve performance of the application. Whenever we are creating indexes, then those indexes information, automatically stored in data dictionaries. For example, which data dictionaries? I will tell you, don't worry. Data dictionaries. Hello, it is audible? Hello. Yes. Okay. Now, today, concentrate. Why? Because how indexes are working, what is that one, row ID, so many things, B-tree indexes, those all the things I'm telling. That's the most powerful concept. And now here, check it out. You are not creating indexes also, you must familiar those all the things. Before that one generalized concept I am telling. And now check it out, concentrate. So many fellows having a doubt only. Why indexes columns we are using in a where clause or order by clause very fastly retrieve the data? Why normal columns does not retrieve the data very fastly? Reason is there. What is the reason behind that one means? Observe here. Every database, what happened? Observe here. Suppose slowly observe. Same like exist operator, you have an idea, no? Same concept is here also working. Suppose this is a salary column, best example, easily understandable. Whenever salary column is there, in this case here, 9,000 is a salary, for example. 2,000 is a salary. Here, 8,000 is a salary. Here, 4,000 is a salary. Here, 5,000 is a salary. Here, 3,000 is a salary. Here, 6,000 is a salary. And also here, 7,000 is a salary. Something is there, for example. Now, this is a table. This is a salary column is there. Observe it here. Concentrate here. What happened? Observe here. Normally, you are also writing a queries. Suppose in this case, I'm writing a query. Select a star from EMP where salary is less than. Now here, yes, 5,000. I'm writing. Whenever I'm writing a what, this query, what happened? Observe here. First control goes to where? Table. And control goes to where? From class first, no? Now here. Then control goes to where condition. In that where condition, first row it will be taking. Control goes to first row. So now first row, so now here 9,000 is less than 5,000. No, this is false. Again, control goes to where? Second row. Here 2000 is less than 5000. Yes, that's why this record it will be retrieved. Again, third row. Now here observe here 8000 is less than 5000. No. So now here observe here. No, like this. This is false, no, where condition. Again, 4000 is less than 5000. Yes. Now here 4000 is less than 5000. Now here again next row it will be searching each and every record, it will be searching only. Here 5000 is less than 5000. No, less than or equal to means okay. Again here 3000 is less than 5000. Yes. Now here yes only. Now that's why 3000 is less than 5000, it will be retrieved. Again next row. Now here 6000 is less than 5000. No. Again 7000 is less than 5000. No. That's why observe here all the records it will be searching. Top to bottom, how many millions of records are available also. Those millions of records are searching. This is called index scan method. Index scan method only. In every database also, whenever we are executing a normal queries means record by record, record by record, record by record. All the records, millions of records, 1 lakh records are available also. 1 lakh records also, it will be searching. Then where condition true or false. Whenever where condition true, those records are retrieved and the remaining records are does not retrieve. That's why this process is very slow, because each and every record it will be checking. Whenever table size is very big, then automatically very slowly retrieve the data from the database. But whenever you are creating an index, what happened? Different. Suppose I'm creating a index on the where this column is salary column. Create in a Oracle side. Create index name on, okay, anything A1, N1, index name 1, A, B, C, X, Y, Z on. Here EMP, what is the column name? Salary column. Whenever we are creating a index on the where this salary column, then automatically this what happened, observed here. In every database in the worldwide, whenever we are creating an index on the where column, then automatically that column values are automatically sorted. There is a beauty. The sorted values, sorted means ascending, descending order, you have an idea or not? Sorted ascending values only, automatically it will be storing. Those sorted values are stored in a very separate entries, that is called index entries. That is called index entries only. Now, a separate area it will be storing only. That is server is responsible. In every database system in the worldwide, whenever we are creating an index, then automatically those index values are separately sorted. Those index column values are separately stored in a index entries only. And now here check it out. Here sorted in ascending order, not a descending order, ascending order. Suppose here ascending order means here 2000, lowest values to highest values, no, 3000, 4000, here 5000, here 6000, here 7000, here 8000. For example, in this case here 9000, like this only, 8000 and 9000 like this. Now, whenever I am requesting a query, observe it here. In this case, record by record is searching, but here now again I am requesting a query. Select a star from table name. Whenever we are requesting a query, select star from EMP where salary is greater less than 5000 means first control goes to table, then control goes to where salary column only. This salary column index is available or not, checking in a data dictionaries. Here these index details are stored in a where data dictionaries only. Whenever this index is available in a where information is available in a data dictionary, then control goes to where not a table, control goes to where index entries only. That is important. Not in a table. Table it does not search. Whenever where condition column having a indexes, then control goes to where? Control goes to where? Index entries only. In that index entries, it will be checking. Yes, here 2000 is less than 5000. Yes, okay. Yes, sir, 3000 is less than 5000. Okay. 3,000, 4000 is less than 5000 retrieved. 5000 is less than 5000. Yes, false. Whenever this condition is false, execution is stops. That is the advantage. Whenever this condition is false only, execution is stops only, stops the execution, and remaining records are never searched. Yeah, remaining all the records are never searched. That is the advantage in a where indexes. That's why very fast they retrieve the data compared to where these all the things only index scan. Index scan means all the records it will be searching, millions of records. But here up to condition is false only, it will be searching. Remaining occasional values are never searched in a table. That's why millions of records are available. Also condition is stops the execution process. yes here exit only, then automatically very fastly retrieve the data. That is important. That's why in every relational database system in the world, right, whenever we are creating a what index on the column, then Oracle server, SQL server, DB2 server by default uses ascending order on the column data. Ascending order, then that data is sorted separately, that is stored in index entries. Whenever user requesting data by using indexed columns in a where clause or order by clause, then directly database servers retrieve data from index entries, not in a table. That is most powerful. That is nobody knows. In that case, whenever up to condition is false, the data is retrieved. Whenever condition is false, then remaining number of records are does not search. That's why that process is very fastly retrieve the data compared to where index scan. Index scan is compared to where now here a full table scan only. Full table scan means record by record, record by record, record by record, record by record is there. But index scan means it separate that one only. And now here write it. These big diagrams are there, B-tree indexes, all the things I'm telling. Then generalized way, first write it. Write it next pair. In Oracle, whenever we are creating index on table column, whenever we are creating index on table column, then Oracle server by default uses ascending order on the column data, and also that data the data means sorted data, okay, ascending order, and also that the data is separately stored in index entries. It's called index entries. How means I will tell you bit index diagram. Index entries separately stored in index entries. Whenever user requesting data by using indexed column, then Oracle server directly retrieve data from index entry, not a table, okay, index entry. And also whenever condition is false, whenever condition is false, and also whenever condition, then Oracle server does not search. Oracle server does not search remaining records within index entries. That's why this process, very fastly retrieve data from database. Okay, now concentrate. How means practically we are learning, don't worry. Now we are checking also. Now concentrate here. This is why indexes are very fast to retrieve the data. That is a process. Okay, next. Now very important. Suppose whenever I'm creating an index, otherwise primary key is there, for example. Employee number primary key, some fellow is created. In that primary key means automatically some indexes information stored in a database here like this. Separate data dictionary. This is a data dictionary only. User underscore IND underscore columns, user underscore indexes. So many things I will tell you one of these days. Data dictionary. In that data dictionary, index details are there. Employee number, here B tree index means normal. Okay, so now B tree like this. And now here B tree index information is available. What is B tree means? Today we are learning, don't worry. Now, what is my doubt? So now this is employee number column or indexer column is there. What is my doubt means some queries are there in a project side. Here, suppose I am typing a what? Select a star from table name. I am typing. Whenever I am typing about this query, whenever select a star from table name, then Oracle server searching for indexes or does not search for indexes. Very good. Then Oracle server does not search for indexes. This query does not retrieve the data very fastly, impossible. Suppose here, now I am writing a query like this. Select star from EMP where employee number is equal to 7902. I am typing. Whenever I am typing like this where condition, then Oracle server searching for indexes. Suppose here EMP table, again control goes to where condition column. This where condition column having a indexes or not, it will be searching in a data dictionary. Whenever index is available, separate searching mechanism, it will be using only in an index entry. B tree means B tree, bitmap is bitmaps. I will tell you that searching mechanism. Then fastly retrieve the data. That's why whenever we are requesting a data by using a where clause, then database server searching for indexes. Really that indexes are available in a where database or not, it will be checking in a data dictionaries. Whenever that index is available, then very fastly retrieve the data from index entries only by using B tree method, bitmap method. So many things are there. Those methods so very fastly retrieve the data. That's why whenever we are requesting a data by using a where clause, then it will be searching for indexes or not. Yes, in a data dictionary. Now, everybody tell me, suppose here where clause means okay. Now, I try to write a what query like this. Group by class, select employee number, comma, count star, like this only I am writing in my project. From EMP, here group space by, here employee number I am typing. Here also employee number column already index is there. Now here, now this group by clause searching for indexes in a data dictionary, otherwise does not search for indexes in a data dictionary. Very good, does not search. That's why group by clause column name indexer column is available also. Those queries does not improve the performance because it does not search for indexes in a data dictionary. So now that's why whenever group by clause also does not search for indexes in a data dictionary. Suppose in every database, again, I am writing a what, not only group by clause, having clause is there, no, select employee number, comma, count star, here from EMP, group space by here, employee number, for example, here, okay, having clause I am writing, having, yes, here employee number is greater than 7788, something I am writing. Here also employee number is a what index is already there in a primary key means B tree index. In that case, whenever you are submitting this query, server searching for indexes in a data dictionary, no, it does not search for indexes. Having clause is available also, it does not search for indexes. That in a having clause, employee number column, sorry, in this example side, employee number column having indexes also, it does not search for indexes. Next, last clause only is select a star from EMP, I am writing. Order by clause I am writing. Order by employee number I am writing. Now here, whenever I'm using a what requesting a data by using a order by clause, in this order by clause column having index means it will be searching for indexes. Yes, it will be searching for indexes. That's why only when the which ones index is searching in a where database servers, whenever we are requesting a data by using a where clause and by using a order by clause, then only database servers searching for indexes in a where data dictionary. Whenever that indexes are available in a data dictionary, then only the very fastly retrieve the data from the the index entries. How can I miss? I will tell you. That's why whenever in all relational databases, whenever we are requesting data by using a where clause or order by clause, not a group by, not a having. Okay. Yes, then only database server searching for indexes in a data dictionary. Whenever those columns having indexes are there, then database servers fastly retrieve data from the database by using index scan method. What is index scan method means? Today I am telling. Whenever we are your where clause or order by clause column does not have indexes, then a database servers retrieve data from database by using a full table scan. Full table scan means first record by record, record by record. I'm showing you that one only. That's why you only one by one by one by record, it will be retrieved only. That theory, write it. Write it next para. This is very important. In all relational databases, whenever we are using, sorry, whenever we are requesting data by using where clause or by using order by clause, then only Oracle server searching for indexes in data dictionary. Whenever those columns having indexes, then database servers very fastly retrieve data from database by using index scan method. Whenever, write it again, whenever where clause or order by clause column does not have indexes, then database server retrieve data from database by using full table scan means record by record. Full table scan method. completed up to this one universal concept in a web database by indexes very fast to the data. And all the queries searching for indexes, no, only order by clause, where clause columns having indexes are there, then only those columns indexes are available or not searching anywhere in a data dictionary. Whenever that indexes are available, how it will be retrieved the data, I will tell you, don't worry. But unfortunately, Oracle side, some other concept is there, Oracle, in a Oracle side. Suppose, slowly observe here, very interesting. Here, Oracle side, here, employee number column is there. For example, this is a primary key, already have an idea. That's why primary key you are creating means B tree index is already there. Okay, what is B tree? Today we are learning. Okay, fine. Now, I am writing a one query. Whenever I am writing this query, then searching for indexes or not, tell me. Suppose here, now I am writing a query. Select star from table name, where employee number is not equal to, so now here 7902, I am writing. Whenever I am submitting about this query, how it will be executed? It is searching for indexes or does not search for indexes? Yes, very good. I am also, you are also thinking nothing is there. Whenever we are requesting about data here like this, first control goes to where clause only. In a where, sorry. First control goes to where, from clause only. In that from clause table, it will be, table is available or not, it will be searching. Then control goes to where clause only. In this where clause, slowly up through here. In this where clause only, now here where clause column employee number is there. This employee number having a what? Yes, here index is there or not, checking in a where index entries. Whenever index is there, a different way it will be searching only. That's why not a record by record. Very fastly retrieve the data. We are thinking that is absolutely wrong one. It does not search for indexes. Impossible. Where clause is available also, that column already index is there also. Oracle server does not search for indexes in this case. Why? In a reason is there? Yes, reason is there. In a Oracle side, another drawback is there. What is that one? Whenever where clause having a what, not equal to, this is a dangerous mechanism, not equal to operator. Or maybe in a previous classes, your idea, is null is operator, one of the stage I'm telling you, is null is operator. Or is not null operator, then Oracle server does not search for indexes if those columns already having indexes also. This is the biggest drawback. That's why in a project side not equal to is null, is not null, queries are there. Those queries does not retrieve the data very fast. Impossible. Those columns already indexes also, it does not search for indexes. That's why not equal to place, so many fellows are not in their writing. Is null, is not null side. There is no choice. Alternative choice is not there for improved performance of those queries. That's why Oracle said, what is the drawback? Whenever where clause column having a not equal to or is null or is not null operator, okay, so operators, then Oracle server does not search for indexes if those columns already having indexes also. Very, very, very important note only. Write a note. This is Oracle side. Write a note, right? In Oracle, whenever where clause having not equal to, comma, is null, comma, is not null, is not null operators. Then Oracle server does not, search for indexes if those columns already having indexes also. And that's why so many interviewer asking, or this is a query is there. This query is searching for indexes or not? Tell me, they're asking. How we are identify this query is searching for indexes, it does not search for indexes means I will tell you auto trace on methods are there. I will tell you those methods also. Don't worry. Okay. And now here in a future, you're a good experienced person means this is a table is there. In this table, in a query, we are writing where employee number is equal to 7566. This query is searching for indexes or not. How can I means in a future set auto trace on explain something is there DBA command. Whenever we are using this command, automatically internal plan tables also visible. And now here, yes. After this command only, whatever query you are testing, only that query we are writing, then automatically that query result and also plan tables are visible. What is plan tables? Next we are telling. Don't worry. This is, yes, here index is searching. Here index scan is there. Internally index is searching only this query. That is a row ID. What is row ID? How it will be working? I will tell you. This is an index name only. Already index name is a what? PK underscore MP primary key name only index name. That's a low. Okay, 0 means okay, so no performance very high only index cost, repeat cost only. That's why internally it will be searching for indexes. Suppose I am writing a what another query not equal to I am writing something. And now whenever I am writing a what not equal to here, it does not search a indexes. This is full table scan, not a index scan only. Here, yes, index name is not there. It does not search. So now whenever not equal to operator is there, is null is there, is not null is there, already employee number, primary key is, employee number in the B tree index is available also. It does not search for indexes. So now here cost is very high means performance is very low. These type of things, and next we are learning only. What is this one or how it will be searching. Those all the things I will tell you. That's why always whenever not equal to internally, these all the things predefined. Not equal to is null, is not null operators are there, then Oracle server only, Oracle side does not search for indexes. If already indexes are available also, anybody creating index also no use. Suppose here, observe it here, I am creating a index on ename column, for example. Suppose here. So now here, this is the ename column is there. Don't start from here. Create index name ABC anything also on EMP. Here ename is a column. This is a bit index. Don't worry. Next bit what is that? These index details are stored in a somewhere in a data dictionary only. Okay, fine. Which data dictionary later? Now I'm creating a what? Set auto trace on explain something commands and type. Through this one, just observe it here. Really, it is searching for indexes or not. Check it out. Select star from EMP where ename is equal to code I am writing. This is a where condition column. Not equal to is not there. That's why this column internally searching for indexes or not. Yes, searching for indexes in a data dictionary. Really, that is correct. Yes, index scan is there. What is index range scan? I will tell you. Don't worry. And now this is the index name is there. CP cost is less only. That's why performance is very high. But whenever I am writing a what not equal to here, not equal to operator. Here not equal to here, the same query I am writing like this. Whenever I am using a what not equal to operator, already index is there also. It does not search. Full table scan is there. Here index is not there. That's why internally indexes it does not search. That's why this query does not retrieve the data very fast. And normally retrieve the data. But how it will be searching? What is that one means? We are learning in our class side only. Not only predefined primary key based only, any indexes we are creating also this one. Okay, that's why I first observed here. Yes. How many ways in every database creating indexes? 2 ways. Whenever in every database primary key or unique index is there, unique constraint is there, then Oracle server, SQL server, DB2 server only automatically creates B-tree indexes. What is B-tree index? Today I'm telling, don't worry. And also why indexes columns only very fast they retrieve the data means sorting internally ascending order only that the column data is separately stored. Whenever condition is false, it does not search remaining number of records. That's why maybe this is a fastest way it will do the data. Again, same like a exist operator is there, no? That execution also false means it does not execute the remaining records or not. Yes. Here also same. Next. Yes, actually, whenever only so many queries you are writing, also all queries does not search for indexes in a data dictionary. So only where clause is there or order by clause is there. Those where clause column or order by clause column also only searching for indexes. Remaining group by having those all the queries, normal queries, cell star from table name. These queries are does not search for indexes. That's why those queries does not retrieve the data very fastly. Again, what I'm telling in a Oracle said one drawback is there whenever where clause having a not equal to is null or is not null operator, then Oracle server does not search for indexes if those columns are already having indexes also. So many times repeated this one. Why? Because so many fellows are indexes only interview questions nowadays they're asking. Why? Because indexes means you are not working really. Only database administrator creating indexes. That's why interview questions, more questions they're asking only indexes. These answers you are telling me is impression is very good because this is subject oriented actually. You are not working also, oh, you are good at what subject means, oh, yes, impression is good. That's why these are all the things interviewer are asking. Like next, so many questions are there, don't worry. Okay, now up to this one. Next, Oracle, how many types of indexes are there? Mainly two types of indexes. One is B tree, another one is bitmap. That's why up to now B tree I'm not telling. In that B tree, again, function-based indexes also there. Through that one, virtual columns is a concept we are telling. Those are all important. Write it. Next paragraph. Oracle having two types of indexes. These are first one B tree indexes. Second one bitmap indexes. Today we are starting very important one, B tree indexes. Your database also B tree there, don't worry. B tree indexes. Sorry. Write this one. Oracle having two types of indexes. Basically, these are first one B tree indexes, second one bitmap indexes. First, side heading B tree indexes. Suppose in a Oracle side, anybody primary key they are creating, unique constant they are creating, otherwise create index name, something they are writing. These all indexes are by default B tree indexes. What happened, how it will be searching is very, very interesting. I will tell you. Write it. In Oracle, by default indexes are B tree indexes. When B tree indexes. Now suppose B tree indexes explicitly you want to create it means syntax rating. Syntax. Create index. Index name on table name. Here column. Create index name on table name column. Okay, now onwards, everyone concentrate 5 or 10 minutes concentrate. Very, very important. Don't write it today. Now onwards, anything. Why? Because big concept. What happened when we are creating a B tree index as row ID, something, so many fellows are writing a theory only, row IDs and all these things in a Google, in a vocation of thing we are observing means. What happened, those things means I will tell you today, algorithm based only, roughly I'm telling. Then ename side I'm telling. Don't write it 5 minutes only or 10 minutes. Concentrate. With this based only, diagram based only, how it will be all the things understandable. Then only I'm telling the what theory. most powerful. What happened? Observe it here, reality side. Suppose this is a EMP table is there, don't write here. EMP table is there. For example, just observe it here. Employee number is a column is there. Here, E name is a column, your job is a column, your salary is a column, so many columns. Slowly observe it here, very interesting. For example, I'm taking employee numbers are 1, 2, 3, 4, like this. Okay, just idea purpose. Don't write, just very interesting. So, I actual execution. So many things. Okay, now, here some data is there. This is a original table. Now slowly observe it here. This employee number column regularly using in a project side where clause or order by clause in my company side. But unfortunately, this regularly used column in a queries means very slowly retrieve the data because millions of records are there in a table. But my database administrator decided in a performance tuning concept side, whatever regularly used column where clause or order by clause, that column better to create an index. Whenever we are creating a what index, then anybody developers are retrieving a data by using a what where clause order by clause, very fastly retrieve the data. They are decided database administrator. That's why they are creating a what index. For example, database administrator only creating a index. Don't write it. DBA person creating an index. How they are creating an index? 5 minutes observe here, very important. Don't write it anything today. Create index on EIN1 on EMP here, employee number column. For example, whenever they are creating a what index, what is the purpose? Okay, they want to, their intention is good. They retrieve the data very fastly. Whenever they are creating an index, these index entries stored in a data dictionary internally. Okay, yes. Internally within a data dictionary, that the details are stored. I will tell you which data dictionary are. Now what happened whenever they are creating a what index means automatically separately this column values are separately storing. That is called index entries. How it will be storing a what index entries means this is a by default B tree index. In a B tree index means tree structure. Slowly observe it here. This is a what a root node. In this root node only, don't write it. This is a binary tree. Now root node internally. Now here, yes, Oracle Corporation giving employee number column is there. No, this column value. So 1 to 14 is there roughly. This algorithm based. 1 to 14 details. Okay, numbers are there. For example, 1 to 14 numbers are there or not? Yes. This is an algorithm based only executing. Algorithm based. Binary tree algorithm is there. This 1 to 14 numbers automatically split it into where half of the values. B tree means two nodes are not. Yes, here like this only. Now observe it here. What happened? I will tell you those all the things. Today roughly I'm telling only. Next, okay, more value, less value like this. So I will tell you original algorithm. Here employee number half of the value 1 to 7. Okay, fine. Slowly observe it here. How it will be searching next time. Half of the value. Here, roughly, employee number 8 to 14 only, it will be storing index entries like this. Is a binary tree algorithm. Again, this node is split into where 2 because binary tree, no? Yes, here, B tree. Here, this is a node internally. And now here also, this is again, it will be split here. Here, this is a node. Here, this is a node. Now check it out. Slowly observe here. Something is there. Today don't write it. Okay, just observe it how it is working first time telling. And now here, less value, more value, there is a later. First, roughly. And now here 1 to 14 is there. And then half of the values 1 to 7, 8 to 14 is storing in a where? In this branch only. Now here, observe it here. Now here 1 to 7 means maybe half of the values 1 to 3, roughly half of 1 to 3 values are storing here. Again here 4 to 7, it will be storing in a where employee number here. Again here 8 to roughly 8 to 10 or 11 values are storing here. Anything half of the values I am taking. Okay, 12 to now here yes 14 values it will be storing over here. Okay. But unfortunately, up to this one, okay, now here, but unfortunately, this is a root node. This is called a root in a B tree structure side. It is index entries only separately storing. But unfortunately, here, observe it here. This is called a root node. This is branches only. But here, this is called last only. That is called leaf blocks. They are called it as a blocks only. Very, very important. Leaf blocks only. Block is the lowest storage element in a where Oracle database. That is a DB concept. Don't worry. Bits, bytes, blocks, so okay, extends, segments. That segments tie up with the what? The data files in the internal storage structure. Suppose here these are the now here some nodes are there. Here in this node, here leaf blocks are there. Those leaf blocks stores a what? Row ID. Very, very important. This is a key concept. So next ename column side also I'm telling row ID it will be stored. Suppose see here one is a employee number is there no sorting data 1 here 2 and 3 it will be stored. Actual data is storing a what in a leaf blocks. These are leaf block stores a what actual data along with the row ID Suppose here internally row ID is there. Suppose here big row ID I'm telling in a where in a previous classes or not in a MySQL subquery chapter side. Here suppose A is a row ID, AAB is a row ID, AAC is a row ID. Big 16, 18 characters are there or not. That's why always these are row IDs are storing actually along with the actual data. Here also, here these numbers are storing a what 4, 5, 6, 7 in this example side 4, 5, 6, 7. This actual data is storing along with the row ID, Here row IDs are there. That's why leaf block stores actual data along with the row ID in a B tree structure. That is a key concept actually. And now here, suppose for example, AAD, AAE, AAF, AAG, okay, something only it will be stored. Now here also actual data is storing in a where along with the row ID. Here also actual data is storing along with row ID. Observe here. That's why whenever we are creating a B tree index, always in a tree structure, leaf block stores actual data along with the row ID. Okay. Now here also row IDs are there. You are observing or not in your table also row IDs are there. And now here in a table also row IDs are there. How much different is observed here. This is a row ID means row addresses are there. These row ID details and actual data is stored in a where? In a leaf blocks only within a tree structure. This is a tree structure. This is the original table. Now here what they are telling, observe here, what happened in a searching mechanism side here, AA is there, AAB, AAC, AAD, again AAE like this only, AAF, and now EFPH, and now AAE, and now here yes like this only, AAF, AAG, like this, so many details are there. Now I am writing a query. Developer doesn't know these all the things. Internally, the data is available here like this. Now I'm requesting a what data? What happened? Observe it here. Suppose I am requesting a data. Select star from EMP where now employee number is equal to 5. I'm giving. For example, now I am requesting a data like this. Now here what happened? Observe here. Select the star from EMP where employee number is equal to 5. I am writing. Whenever I am requesting a what data like this only, for example, in this example, first control goes to table, control goes to where clause not equal to operator is null, is not null, not there. That's why it will be searching for indexes. This index is available or not in a data dictionary, it will be searching. Yes, this index is available. That is a B tree index. Whenever B tree index is there, control goes to where? In a tree structure, not a table, index entries. In this index entries 5, it will be starting OS. 1 to 14 numbers, 5 is available. Now that 5 is, so now here, yes, here, half of the thing, it will be searching only on of here, less than, okay, so now half of the values. Here 5 is available in a where in between 1 to 7 or in between to 8 to 14. It's less than or greater than next first observe here. Here only, yes, it is available. That's why it does not search 8 to 14. Again, in 1 to 7, here again 1, 2, 3, 4 to 7 is there. Here it will be control goes to here only. Again 4 to 7 means this total okay, range only it will be searching. 4 it will be searching. 4 is equal to 5, not 4. Again 5 is searching, 6 is searching, 7 is searching. But 5 is equal to 5 matching only. This is E only. A, B, C, D, E. E is a what? Row ID. This row ID, where the row ID is available, here only it will be matching. And now with that corresponding data, it will be retrieved only. That's why always E only, and now corresponding data, it will be retrieved like this only. That's why always whenever we are submitting a what, whenever we are requesting a cell star from EMP where employee number is equal to 5 means, yes, it will be searching it differently. It does not search these all the nodes only you are observing or not. Yes, here some part only it will be searching. This is called index scan method. Where the which one index range scan here. Why? Because this 4, 5, 6, 7, these all the values it will be searching. That is called range. Whenever E5 is equal to 5 is true, then that row ID it will be taking where that row ID is available. Directly communicate with that row ID. It does not search all the records only. Very fastly retrieve the data. That's why a different way it will be searching or not. That is called yes index scan method. That much of powerful. That's why in Oracle, whenever we are creating a B-tree index, then Oracle server internally automatically create a tree structure based on indexed column values. In this tree structure, always leaf blocks are there last only, stores actual data along with row IDs. Whenever user requesting a what data by using a where clause or order by clause, then Oracle server first checks those where clause or order by clause columns having indexes or not. If those columns having B-tree index, then Oracle server directly retrieve data from leaf blocks by using index scan method in B-tree structure. How means always whatever occasion of your matching data is there, then that row ID it will be taking. Where the row ID is available in a table, in that one only, that matching only. Now directly retrieve the data from that table only. That's why index entries, in a index entries only it will be searching. That's why that is very fastly retrieve the data from database. That's most powerful. Those are all the things, theory and also another diagrams are there. Those are all the things. So tomorrow I will tell you. Don't miss the class tomorrow. Why? Because index data entry. Okay, so now data dictionaries and also how we are find out a query is searching for indexes. It does not search for indexes. That is a DBA concept. Auto trace on explain plans. I'm telling only. Okay, na? Then only based on this bitrate extension function based index is there. Based on that one, virtual columns I'm telling. Then only bitmap indexes. These are all the things very important. Okay, na? Just up to this one is enough today. Tomorrow I will tell you connect to PLSQL. Okay, yeah. Tomorrow I will tell you. Thank you. PLSQL connected. Okay. Yeah.